Welcome to Lab 1 of Physics 2212, Charge Tapes. Okay, so the purpose of this lab is to observe the interactions between charged pieces of tape and determine how much excess charge is on one piece of tape. So we did this experiment in our groups, and then we made a computational model on GlowScript to find the excess charge. A preview is that the charge of our each tape was found to be 9.05 times 10 to the negative 8 coulombs, and the number of electrons lost by each tape was 5.06 times 10 to the 11. So some main concepts that we'll use is Coulomb's law, which describes the electrostatic force of attraction or repulsion between 2 point charges. Newton's second law, which is when a system's change in momentum is directly proportional to the net force acting upon it. And gravitational force, which is when the attractive force between any two objects with mass pulling them together. So these are the equations that we'll use for that. We put these into GlowScript for gravitational force, Coulomb's law, and then momentum principle. And all of these are going to our GlowScript code. So the experimental procedure that we use for this lab, we cut two pieces of tape and use them to make two U-tapes. Then we rub a pen on cloth and use it to determine the sign of the charge on the tape. We float one of the U-tapes over the other, as seen in the picture. We then determine the distance of vertical separation between the centers of the two tapes, and we use this observation to calculate the charge on the tape. And then using GlowScript, we write a function to calculate the electric field produced by a point charge. In this experiment, our system is tape B, and our surroundings are both the Earth and tape A. So what are the initial conditions that we have? Well, we have the tape length for both A and B, which in our group we found was to be 26 centimeters or 0.26 meters. Our tape mass we calculated using the instructions on Canvas, which was multiplying by 1 gram per meter, and that gave us 2.6 times 10 to the negative 4 kilograms. Our tape width was 0.02 meters. Our tape area was 0.0052 meters squared. Our atom area was just the 1 times 10 to the negative 10 squared, and we found the number of atoms by taking the tape area divided by the atom area, which gave us 5.2 times 10 to the 17 atoms. Our separation distance was 0.17 meters. We put all of this into our initial conditions on GlowScript. And what calculations did we do? Well, first, we found the force of gravity, which the equation was shown before, and it points negative 0.00255 in the y direction because it's just mass times gravity. And then the electric force was basically just the negative of the force of gravity because they sum up to 0. So it's 0.00255 newtons. And then we plug that in to find the charge of the electron on tape B, and using Coulomb's law, which is 9.05 times 10 to the negative 8 coulombs. To find the number of deficit electrons, we would divide that by the charge of a proton, which is 5.65 times 10 to the 11. And then to find the ratio of electrons to atoms, we would divide the number of electrons by the number of atoms, which gave us 1.09 times 10 to the negative 6 electron over atom. So our computational model, what does it show us? Well, we put our initial conditions on the picture on the left, and we calculated the charge. We then use that to find the quantity of electrons transferred per tape, and we also use that to find the atomic density ratio, or basically how many atoms per electron. And then we also calculated the electric field at the upper position and the total upward electrostatic force on tape B. And all of this was done in the for loop or updating it. And these numbers match our calculations from before. So what assumptions and errors do we have? Well, our assumptions is that the tape is a point charge where the charges are concentrated at the center of the tape, and each charge tape may have an evenly distributed and equal net charge. Now, these assumptions may be false. That's why we call them assumptions. So some errors that we have, that we could have measured the distance between the tapes better, which affects net charge. And by touching the tape, we could also weaken its positive charge. The charge of the tape may also not be equally distributed. So our discussion. What if the electrons had a positive charge and the protons had a negative charge? What would change about the observations you made? Well, nothing would really change about the observations because both tapes would have just flipped the sign and they would have the same charge, so they would repel, which results in the same outcome. And why is it important to handle the charged tapes as little as possible? Well, we said it before. The charged tape could leak away since our hands are electrically conductive, which could disrupt the flow and even neutralize the tape. Thank you for watching my video.